Hello everyone, this is my sixth lecture of dynamics. In the previous lecture, I have discussed two numericals on simple harmonic motion. In this lecture, I will discuss one more numerical on SHM. The question is, a point moves in a straight line towards a center of force mu by distance cube. Starting from rest at a distance a from the center of force. Show that the time of reaching a point distant b from the center of force is a by under root mu into under root a square minus b square, and its velocity then is under root mu by ab into under root a square minus b square. Also show that the time to reach the origin is a square by under root mu. So here center of force is given mu by distance cube. So let O be the origin and let the particle starts from rest at A and move along the line AO such that OA is equal to A. Let P be the point on the axis such that OP is equal to X, which represents that the particle is at a distance x from O after time t. So according to question, the equation of motion of the particle is d2x by dt square is equal to minus mu by x cube. Give it as equation 1, and negative sign is taken as x decreases with time t. Now multiplying both sides by 2 dx by dt, we have 2 dx by dt, d2x by dt square equal to minus mu 2 dx by dt 1 by x cube, which can be written as d by dt of dx by dt whole square is equal to mu d by dt of 1 by x square. So integrating both sides, we will get dx by dt whole square equal to mu by x square plus an integration constant c1. Give it as equation 2. Now initially at a, small x is equal to small a and velocity dx by dt is equal to 0. So substituting x is equal to a and dx by dt equal to 0 in equation 2, we will get c1 is equal to minus mu by a square. Substituting the value of c1 in equation 2, we will get dx by dt whole square equal to mu 1 by x square minus 1 by a square. Give it as equation 3. Now at P, that is for x is equal to b. According to question, we have to find the velocity at a point distant b. So we are taking x is equal to b. So equation 3 becomes dx by dt whole square equal to mu bracket 1 by b square minus 1 by a square. This implies dx by dt whole square equal to mu a square minus b square divided by a square into b square. So this implies dx by dt is equal to minus under root mu bracket under root a square minus b square divided by ab. Give it as equation 4. And again this is the expression for velocity. So we have taken negative sign because x decreases with time t. Hence the velocity at x is equal to b is under root mu bracket under root a square minus b square by ab in magnitude. Now from equation 3, we have dx by dt whole square is equal to mu bracket a square minus x square divided by a square into x square. So this implies dx by dt is minus under root mu bracket under root a square minus x square by ax. Negative sign is taken because x decreases with time t. Collecting the terms of x with dx, we will get minus a by root mu x divided by under root a square minus x square dx is equal to dt. Now we have to calculate the time to reach the point distant b. So for time to reach at x is equal to b, let us integrate the above expression from x is equal to a to x is equal to b and t is equal to 0 to t is equal to t. We have minus a by under root mu integration a to b x by under root a square minus x square dx is equal to integration 0 to t dt. For solving this integration, we substitute a square minus x square is equal to u. This implies minus 2x dx is equal to du, and changing the limits of integration. If x is equal to a, then u is equal to 0, and if x is equal to b, then u is equal to a square minus b square. So the above integration will convert into minus a by under root mu integration 0 to a square minus b square minus 1 by 2 1 by under root u du is equal to t. After integration, we will get a by 2 root mu into 2 1 by root mu. Integration of this is 2 root mu, and putting the limits 0 to a square minus b square is equal to t. So finally we will get t is equal to a by root mu under root a square minus b square. Now we have also find the time taken to reach the origin. So in this equation, time to reach the origin, we want to find this. So in this equation we have to change b, small b by 0. That means the limit of integration will be a to 0. So using this we will get, let capital T be the time taken to reach the origin, then capital T is equal to minus a by root mu integration a to 0 x by under root a square minus x square dx. Again using the same substitution as above, this one, we have to put a square minus x square is equal to u. This implies minus 2x dx is equal to du. If x is equal to a, u is equal to 0, and if x is equal to 0, u is equal to a square. So using this we will get this one. Using the above substitution, t is equal to a by 2 root mu integration 0 to a square du by under root u dx. Sorry, du by under root u. So after integration we will get a by 2 root mu to integration of 1 by root mu is 2 root mu, and the limit is 0 to a square. So finally we will get a by root mu into a, that is a square by root mu. So this is the proof. This is enough important examples from chapter 1, simple harmonic motion. In the next lecture I will start the next chapter, Hooke's law. Thank you.